This is a bit of an oddity because it came from a British supplier and it's a dusk sensor. Let me show you it. We'll try it out. I shall point out some things with it and then we'll open it up and reverse engineer it. So it was cheap. It came in from CBC in the UK at £2.69 inclusive. For very little more, for £5, you could get one with the bayonet cap off top, so you can change the sensor, and you could add a gland to it, and then you can terminate cable in and have a fully watertight, compliant installation, so to speak. But this one is odd. It struck me as being very Chinesey looking, the sort of thing you'd buy from a Chinese seller on eBay that was perhaps circumventing British regulations. So if I stick the little bracket in like this, here we go. So it goes down onto a pin to alignment. You can change the direction. And the instructions then say, after the usual bit, this sensor must be installed by a qualified electrician in accordance with current building and IT wiring regulations BS 7671. It then shows it mounted in a wall, and it says don't mount it underneath the light, mount it above the light. But if you mount this in a wall, you've got single insulated cores coming out of it. There's no way to actually terminate an actual like flex into it, or a rubber, a suitable outdoor rated flex. And I could see these being bought and handed to facilities management operatives who maybe don't have the full electrical knowledge. They're very much just fixer-uppers. And they'll just go ahead. If they're given this, they'll think that's fine and they'll install it. And I can't think of any way you could just, even with a junction box right next to it, you're going to end up with single insulated cables exposed, which doesn't really comply with electrical regulations. The only way I could see this being used is if you actually had it in a dome, some enclosure with the light underneath it, so that it was shielded. So this was, or in a, I don't really know. I don't know what maybe it could be mounted in an outdoor plastic box or something like that. That's all that comes to mind. Which would work, a clear fronted box, it could work. But let's get the hobby up. It's got brown for live. Let's get the wires stripped here and red to go in. And I shall cut the red short at the end because it will become live when I test this. I get the feeling that someone has just added it without really thinking this through, but it doesn't matter, it's happened. So if I stick this in here, and I stick this one in here, actually, you know what, I'll take that bracket off the bottom. It's just going to get in the way. I want to stand this up the way. Oh, that's it off. And I'll tuck that wire out the way so I don't finger it. And we'll plug this in. So electrically, it's showing a current of about 25 milliamps. It's showing absolutely turbo power factor of 0.1, which means it's probably a 24 volt derived supply inside from 240 to get that sort of result. Power is just 0.6 watts standby. Right, okay, tell you what then, I'm going to turn the light off. I'm going to take the exposure off. Turn the light off and we'll see how long it takes to activate. We'll hear the relay click. 1, 2, 3, 4, 5. It took 6 seconds. Now, do I have a little flashlight I can shine this? I should have thought of this before fingering about amongst live connections on the bench. I'm going to shine a flashlight on it. We'll see how long it takes to come back. 1, 2, 3, 4, 5, 6, 7, 8. It took about 8 seconds. So 8 seconds to react to daylight again. So there is a slight time delay there. And click again. Okay, it's relay based, that's good. Watch your eyes, the light is coming back. Let's open it and see what's inside. So I shall disconnect this. I'll short them together just in case it's got a little nasty surprise, because it will almost certainly with a power factor like that be based on a class, well, a capacitor dropper. This one, unlike the cheapy Chinese ones, the super cheapy Chinese ones, doesn't just clip in. This one is removable, look of it. Don't know if there'll be a seal or not. It is rated IP44. That means it's rated to prevent ingress of sort of 1mm diameter objects or more, and it's designed to be splash proof. So there's a relay, there's a capacitive dropper capacitor, there's the little LDR actually stuck right down between those capacitors in there. That's quite odd. Let me just zoom down that. That's quite an odd place to put it. I wonder why they specifically put it in there. Let's get the circuit board out. I'm guessing that if this is anything like the usual Chinese ones, it'll have a 555 in the back as a little voltage reference and a relay driver. Oh, the potentiometer's capped in there. There's not a lot. I'm seeing a rectifier. Seeing what looks like a big zener. A couple of diodes, resistors, and a transistor. Is that some threshold device or something like that? Or is that just a standard transistor? Tell you what, I'm going to pause momentarily and reverse engineer this. I shall be back in a moment. I'm back, and that is perplexingly simple. That is the simplest one of these I've ever come across. The transistor is just that. It's a transistor. So the supplies come in. There is the bridge rectifier. There's the Zener diode, or Zener diode, as some people like to say, clamping it to about 22 volts. There's a smoothing capacitor, and then I'll show you the schematic. That's the best bet. So if you want to try a little bit of reverse engineering yourself, here is the back of the circuit board. And here's the front, but it's not flipped round, so you'll have to allow for that if you are having a go at reverse engineering. Things worthy of note: 24 volt relay, 330 nanofarad capacitor, but it's rated 630 volts, which is good. That should give it greater longevity. There's the little cadmium sulfide LDR. Despite reduction of hazardous substances, trying to get rid of these because it's still the best thing for this job, and it uses a tiny quantity of cadmium, but cadmium is one of those sinful metals. Oh, and there are things where they note the 100 ohm inrush and fuse resistor, if you will. It's kind of, it's multi-function. So here's the circuitry. I shall nudge down just a little bit more. Let's get closer. Let's get closer. So the supply comes in, the neutral goes to that 100 ohm resistor, and then to that capacitor. 330 nanofarad, 630 volt. There is a 1 meg ohm resistor across the back of that. I have to say that's a bit squirmy because of its size, particularly in something that could get damp outdoors. You know, there could be sort of humidity forming in it with temperature changes. I'd rather have seen, you know, there's plenty of room for it. I'd rather have seen them actually use a couple of resistors in series for that. But they didn't. The switch contact goes to the live via a relay contact, and then the live goes to the bridge rectifier. Through the lazy bridge rectifier, and the Zener, this circuitry is so simple, the Zener diode clamps that to about 22 volts or so. There's a 100 megafarad smoothing capacitor rated 50 volts. Then a resistive divider. There's a 100k resistor in series with that little variable potentiometer, the little adjustment device. And then the other side of that is the LDR, the light sensitive resistor pulling to ground. And as the level of light increases, as daylight arrives, this will pull harder to the 0 volt rail, meaning the voltage in this here actually lowers down towards that rail. And likewise, as it gets dark, this resistance goes up, and then these resistors pull it up positive. It goes through that diode, and there's a capacitor in here. This is the time delay capacitor. It's 100 microfarad again, 35 volt. They could have just used 100 megafarad 35 volt there as well. I don't know why they used 200 megafarad capacitors, but with different voltage ratings. Then it simply goes through a 47k resistor to a transistor, and the transistor, as it gets darker, gradually increases the current through here until the threshold of the relay clicking in. That's it, and there's a back EMF spike suppression diode across the relay coil. And likewise, when daylight returns and the LDR starts pulling the base effectively down to the negative rail, the transistor gradually turns off until the relay finally clicks out. It's very, very, very simple. Not really much to say about it. It is one of the simplest I've seen, but I suppose ultimately it works. I wonder if that transistor there dissipates bit of current. But having said that, it's a 24 volt relay. It's quite a small one. It's probably not very high current through the coil. But that's it. Very simple, very uncluttered. I really was expecting something like a 555 on that as both the voltage threshold detector and the sort of the relay driver. But this has just been optimized around these components. Very interesting. Very neat how they've done that. But yeah, I'm not sure how this has ended up being sold. As I say, I could only really see this being usable inside an enclosure with clear cover. So this is the single insulated wires are inside that. But there you go. That's how it is. But interesting little thing. It was interesting to see. It's a nice, simple design. It would almost, you know, the thing that would improve that would be a cable just terminated, a half-meter length of cable, maybe a 1.5 foot cable coming out of that, pre-terminated, and then it would effectively be compliant, weather compliant, because you could take that cable straight into the junction box. But this ain't so good. But hey, it is what it is.